people asking for things like microservices or very specific technologies before they even make the decision to go with those. Oftentimes go with those because that's what everyone else is asking for, and let's just kind of copy what everyone else is doing. And it's again, it's another symptom of this. Big tech worship, if you like, where everyone kind of just follows what the Googles and Amazons and other big tech companies is doing. They're using containers, they're building microservices, which do the same thing. But what works for Amazon probably is not going to work for you if you're like a 10 people company that's selling cupcakes. You don't have the same level of traffic, you don't have the same level of organizations. Microservices is great for scaling organizations, not for your applications. So now, if you don't need to scale your team to 200 people, you probably don't need microservices.
And we're live. Hi. Hi, Scott. How's it been?
I'm still alive. How are you?
I'm good. Yeah, had a rough week last week, but yeah, everything is going really well.
Cool. So we started a new thing, Odie. We one is I think we're up to like 218 subscribers.
Yeah.
Two videos, the business of F sharp and then the business of Scala. Those probably contributed to I would argue 3/4 of our subscribers, and we've been recording videos. Has it been for 8 weeks, 10 weeks?
Yeah, like 8 weeks thereabout.
Okay. Yeah, so I'm going to go ahead and read a comment. It's on the business of F sharp. And Odie, you and I both discovered Yan Trey on his episode with .NET Rocks, in which he was discussing the productivity of F sharp. So I'm curious if he has any thoughts about this comment that I'm about to read right now. So the comment is, and maybe I should share my screen.
Yeah, no need. Just go ahead.
No need. Okay. The comment is from Inzonuez, and I'm sure I butchered that internet handle, but that's the person that left the comment. It says, for me, that I work with C Sharp every day looks like an awesome language. I read the docs and experimenting with .NET Core with F Sharp. I think the real downside with this kind of languages is that it depends on other languages. In this case, C Sharp. The cognitive charge of having to know C Sharp and also F Sharp, it's too hard for beginners or not too advanced programmers like me. For example, if you have to make a web API, then you will have to use ASP Core and know all the related classes. You have to know the BCL of .NET Core itself, and that is with everything. If you have to work with SQL, then you need to know how to work with Dapper, for example, and then translate it to F Sharp. It's too hard for the majority of projects, right? And this was, again, us discussing the business of F Sharp with Don Syme, and I think what the commenter in Zone Nuez, I'm butchering his name, was saying is F Sharp is a great language. However, when you need to maintain .NET code or plug into the .NET ecosystem, F Sharp becomes rather challenging because how do you adapt F Sharp to existing .NET infrastructure that was written in C Sharp and the idiomatic C Sharp practices? That's what I captured from the comment.
Yes. Yeah, so I think it's a valid comment. Um, I would say though that it doesn't really apply per se because C sharp, F sharp is almost a superset of C sharp in a way. You can still write what is idiomatic C sharp in F sharp. You can still use your classes, have your assignment, your mutability, and all that good stuff. So, as much as it sounds daunting to still learn, like, okay, after learning in any particular library or project, having to do that the same thing in F sharp, I think if you really understand the language of F sharp, it's not a very difficult thing. I remember when I was learning when .NET Core was still new, and it did support F sharp, and I even had to like learn how to. I even had to like do some translations between C sharp to get some entity framework code running and stuff like that. So yes, it's still a hurdle, but I don't think it's as big as the commenter makes it out to be. So yeah, that's my
I would
two
just also
cents.
add that recently I got hip to ChatGPT, and so I really didn't want to port a view model that was written in C sharp. I didn't want to go through the pain of porting it to F sharp, and so I just copy pasted the view model with the C sharp implementation and asked ChatGPT to translate it, and it did reasonably well. So there's
Mm.
some new age tooling that can also help out. Yin
Interesting.
Trey,
I
not sure
think
if you
one of
have
the,
any comments.
sorry, I guess the first thing to say would be I haven't done anything in .NET for a number of years, so my opinions may be a little bit dated. But the thing that I took from one of the key things that I took from the question was the context that for someone who is maybe not an expert on .NET, someone who's still learning .NET, so having to master both languages. Um, and the different practices that's what's idiomatic in C sharp may not be idiomatic in F sharp and vice versa. One of the things that I found quite useful in the past, certainly as I was working with projects where there's a mix of a C sharp code and F sharp code, is to keep C sharp on the kind of outside, where you've got your where you've got your web server, but then you can write a lot of the core domain logic in F sharp, where you can use F sharp's immutability by default and more succinct syntax to things like distributed unions to capture types information that may not be as easy to do in the C sharp. So you can use the C sharp code to write the web server that calls into your domain logic. And use F sharp to implement that domain logic so that you don't have to rewrite everything that you already have in C sharp into F sharp. So both of them runs in .NET, so there's good interoperability between the two languages anyway. So you can absolutely use each one of them in places where it probably makes the most sense. And then at some point, maybe if you're lucky, once you've got a handle of F sharp, and then you find yourself in a project where you are starting from greenfield, then you can say, let's see if we can do this whole thing in F sharp. And within F sharp, you've got libraries that allows you to create the web servers and talk to databases and all of that. Maybe there are wrappers around the other libraries. I'm not really sure because I'm not in the .NET ecosystem these days, but I'm pretty sure any sort of C sharp library, you can probably create the F sharp wrapper around it so that the types and interfaces are a bit more easy to consume coming from F sharp. So that's probably the approach that I would take. Just don't go and try to convert everything to one language, but you can actually use the two of them side by side.
Yeah.
Yeah.
The first thing I
Yeah.
think about is the phrase the functional core with the imperative shell. Hence the
Mm.
functional core being your F sharp or your Scala, and then your shell
Yeah,
being your Java or your C sharp. So
exactly.
Okay. So I think at this point, let's go ahead and introduce our guest, Yan Cui, Yan Cui. Okay. Yeah. Trust me, as an African, I get my name butchered all the time, so I know how it is. So sorry about that. Yes. I think maybe you should just go ahead and introduce yourself. I have a comment after that. So
Yeah, sure. My name is Yan Cui. I've been, I guess, involved in the AWS community since about 2010. That's when I started to, build stuff on AWS. I went through the whole sort of, I guess, the progression of building everything on EC2 to then trying things on containers to then discovering, Lambda and serverless, and then start to build everything on the, using serverless technologies, which I define as anything that not just Lambda functions, but also things like API Gateway, Event Bridge, DynamDB. So anything that allows me to delegate a lot of the infrastructure responsibilities to AWS so that I can just focus on writing things that are specific to my business requirements. Yeah, so I guess my first big serverless project was in 2016 when I was working at a social network, and we had lots of problems with the sort of containerized environment we had, and from scalability to cost to just how long it takes to build anything. And so we gradually used the strangler pattern. We moved pretty much the entire system to running on serverless with a lot of API gateway and Lambda functions. And we kind of developed a lot of the practices around testing, deployments, and CI/CD monitoring, all of that good stuff. And yeah, since then I've been pretty much focused on the serverless space. Nowadays, I work as mostly as a consultant and help other companies adopt serverless. And luckily for me, in the last couple of years, I've had a chance to build serverless systems on very different scales for both enterprise as well as for startups. One of the more interesting environments was working for a company called The Zone, which is a big sports streaming platform. At peak, we have over 2 million concurrent viewers. And so it was using a mix of containers and serverless technologies. And we had some specific rules around when to use which. Based around the limits you have with the different technology choices we have and the use case that we have as well. So yeah, happy to sort of jump into any of these the talking points. You've guys got questions about various different kind of use cases I've had. But yeah, nowadays I mostly work as a consultant, working with some European and some US based client doing a bunch of different kind of things depending on what the client needs.
Okay, awesome. So I'm going to first start by saying I'm a big fan of yours. Um, the first time, the first time I got in contact, I knew about you was during 2013. I don't know if you remember this. This is almost 10 years to the day, right? In 2013, a no, I was working doing .NET C Sharp. Um, I had 2 hour commutes from because I was a developer in Lagos, Nigeria. I had 2 hour commutes where I would go from um, my house to the office. I would wake up like 6 a.m. or something like that. Crazy. No, I would wake up like 5, leave the house by 6, then get to work by 9. So we're talking roughly 2, 3 hours. And in that time, I used to like listen to podcasts and stuff like that. So I heard your podcast with on .NET Rocks, where you were talking about like games, building games with F Sharp. This is way back. And I remember being so fascinated, by some of the things you were saying. And you were talking about like, oh, functional languages like F Sharp have so much productivity to them that, what could take a Java developer like, 4 or 5 days used to could take you like, 10, 20 minutes. And I remember hearing that and being just totally like mind blown. I was like, there's no way that can be true. And yeah, investigating that, here I am, a functional developer, because yeah, I remember you making me hip to like F Sharp and all of that good stuff. So I just wanted to just let you know that it's almost like coming full circle, exactly 10 years and all of that stuff, which is great. Um, yeah, I think the first question I would like to like ask you, right, is in terms of like why serverless? Why should any company use serverless?
Yeah, sure. I mean, going back to the episode you mentioned in terms of using F sharp, being able to write, I was able to make things, write things a lot faster than I was able to do with Java because F sharp gave me tools to describe domains in a more succinct and concise way, so that a lot of domain logics can be implemented much easier without hundreds of different types that gets involved in the process. So a lot saves you a lot of typing. So when it comes to like functional programming, I think one of the big things that made me interested in functional programming was the fact that when you're building applications that are more and more complex, it gives you tools that can better manage that complexity and limit that complexity. And one of the things that I found is that as I'm working with things like services like Lambda, is that there's another sort of angle towards managing complexity is to making some of the complexities somebody else's problem. and also at the same time limiting the unit, the sort of the maximum concurrency that you will have to deal with when you're working on any piece of business logic or feature. And that's kind of where you have Lambda functions, where you've got this very small piece of functionality that is kind of self-contained in a way. And to understand everything given Lambda function is doing, I don't have to look at thousands and thousands of lines of code. Usually, maybe just like 2 JavaScript files, maybe 300 lines of code, and that's it. Even though the overall application is much more complex, much bigger. I guess the business value of a service really is is the ability to allow you to focus on what's important to you, to your business and your customers, so that you can get more done with less effort and faster. And for a lot of companies, also, do get things done in a way that's much more cost efficient as well. So, taking an example, that the social network I was working at, we were a new social network. We have a decent number of people that signed up. They had a strategy around bringing on board the influencers, and then they will run campaigns to their followers. So we have really unpredictable spikes in traffic, where someone who's got 10,000 followers would do something like, oh yeah, interact with my post, like it or whatever, and then at 10 o'clock at night, I'm going to announce a winner from the people that gave me engagement for this designer handbag or something like that. Which for a lot of the sort of fashion influencers we had on the platform, it would drive that just unpredictable spikes in traffic, which meant for one, we have very low sort of baseline traffic, but there's like crazy spikes that goes 10x, 100x against your baseline, which means in terms of just our infrastructure running on containers, we have to keep a lot of instances running, even though most of the time we are using like 5%. But because of these spikes, intraday spikes that we can't predict, we have to keep a lot of redundant CPU resources around just so that we can handle these kind of spikes. And because applications are, just like you got the entire application written in Node.js, and this is where I just wish someone was writing this is in F#, where the code can be more easily understood. Working with Node, there's Node types. This was 2016. Wasn't a particularly well-written application. So I look at any abstraction layer, like with a user variable, they can mean completely different things. I have no idea what I can do with this user object, depending on which module I'm looking at. So in understanding where you've got this node application, you've got this very high ceiling in terms of the complexity you have to deal with. So that's where things like functional programming and types can really help you manage that complexity. But once you start breaking down that entire application into lots of small individual Lambda functions that does one thing, then suddenly the ceiling really gets lower, so that for any one sort of feature, someone trying to add a user or they want to post a new tweet or whatever, there's a very small amount of code that I need to look at to understand what the hell is going on. And when we move to Lambda function, when we move the architecture to serverless, we were able to basically get rid of all the problem we have around scaling. The cost was down by about 10x. So because all the sort of redundant capacity we have to keep running 24/7, even though we don't need it, all of that is gone. We only pay for executions when someone actually uses our system. And the most important thing is that we had this cycle of deployment that takes a long time, and it takes sometimes weeks to get a new feature out. And once we move to serverless, we're able to focus much more on the business logic than to worrying about infrastructure, and people can work on things more separately without having to worry about all touching the same code base. And we were able to get things out in a matter of hours. So sometimes even just having a morning meeting about, okay, like search is not working the way we want. We want to promote users, certain users with more followers so that they're more prominent on the platform. We would talk about the requirements. We go implement it, get it tested, deployed within the same day into production, and then start monitoring with observability, with our observability tooling, all of that. So the ability to get things out quickly and be able to iterate on ideas quickly and efficiently is the number one business value. But depending on who you are, if you talk to some more enterprise, especially people in the sort of finance industry, you may also often hear that people are looking at serverless because of security. When it comes to maintaining your container image, and as well as the underlying infrastructure that runs your containers. There's a number of things you have to do on a regular basis, and that was maybe about 60-70% of my job was just patching machine images, updating scaling parameters and configurations and things like that. And it's hard work and something that I honestly don't do a very good job of. I do my best, but it's probably not as good as it needs to be. But when it comes to Lambda functions, I just worry about my application code and my dependencies. Those are still my responsibilities as before, but I don't have to worry about an entire class of attack vectors like the operating system. I don't need to patch the runtime for my application. I don't need to patch the operating system that runs my code. I don't need to worry about the network security for my EC2 instances, because all of that is taken care of by AWS. So from a security point of view, there's a whole class of things that you can just be compliant for just by using managed services like Lambda and API Gateway and DynamoDB. So talking to a lot of the enterprise customers, security is a big reason why a lot of them are looking at serverless, so that they don't have to spending a lot of effort and manpower and hiring people, so paying for staffing costs just to look after the execution environment that runs your code. But by far and large, for most companies, the business value for serverless is to be able to iterate ideas quickly, get things out, test ideas against the market cheaply, and be able to mostly, just be able to get things done quicker. And that's, I think, the number one problem that most companies face, just in terms of having ideas but not able to execute against the market quickly.
Yeah, yeah, definitely. One of the, I think you just hit the nail on the head. The ability to iterate quickly, the ability to make scale as your traffic comes in and all of that stuff. But also, there is also the reverse leg of it as well, which is usually a very important aspect of serverless, in the sense that if you don't have much traffic, right, you're not paying for what you're not using, which is useful, which tends to happen because we like to think of traffic as this like for forever ending stream, but nothing could be further from the truth, right? Like at night, especially if you're running, in a local business or something like that, at night, there's usually a fall in the amount of traffic. And then during the daytime, somewhere midday, there's also a spike and so on and so forth. So you see these waves and stuff like that. And if you're running maybe infrastructure, like EC2 instances, you'd have to run the same cost all the time. But if you're using serverless, then at off-peak periods, you won't use as much resources, which tends to offset the cost, right? But one criticism I've heard from people who aren't really, fans of serverless, I feel like I need to ask it to you as well, is one criticism is, people saying that the complexity in the domain is still there, but you've shifted that complexity from the code to the infrastructure, right? And doing it at the infrastructure level has a lot of drawbacks and a lot of issues. Like, what would you say to that?
Yeah, I mean, the overall complexity probably doesn't change. It gets shifted around. But the difference is that a lot of those complexities are no longer things that you need to sort of deal with on a day-to-day basis. So if I'm having to deal with the containers, day-to-day wise, I have to deal with in terms of just patching the machines, images, updating them, and making sure that they're compliant security-wise. But when it comes to using managed services like DynamoDB, API Gateway, and the Lambda, those things are still there. Those requirements are still there, but now it's somebody else's responsibility. And also, in terms of, I guess, some of the complexity, some of the things like using managed services instead of having just a blob of code, like one big jar. I now have some Lambda function here, API gateway here. I've got event bridge there that connects lots of my resources together. So I mean, those kind of things, they can add more moving parts. They can be more complex, but the complexity is at least surface into the sort of the your, I guess, the higher level, if you like, into the architecture level, so that you can see it. If I look at the so in my previous example, the social network where it was just running on a bunch of containers, how complex is the application? You have no idea. All you see is three containers. Inside that, it could be 2 lines of hello world. It could be 10 million lines of run Windows or whatever, some really crazy stuff you got there. You have no idea until you really open up the code, looking into the code and figure out all those connections where you may still have those connections in terms of one bit of code there pushing a message to RabbitMQ that gets handled by some other code in some other jar, some other module somewhere else. Those things still exist, but you don't see it. Just because you don't see it doesn't mean that they're not there. And whereas if I was to say having a Lambda function do the same thing, but instead of using RabbitMQ, I'm using Event Bridge and triggering instead of some other module in the same running on the same container is a separate Lambda function. At least those connections are now explicit and surface into the architecture level, so that we can talk about it, we can identify them, and we can look at them and see, okay, right, do we actually need this? It's much easier to have those conversations when everything is on the surface. I mean, when you've got a problem, the first step is to identify and know that you've got a problem, right? So when you've got complexity that's hidden inside those boxes, inside those inside your code, inside your containers, it's much harder to know that's what you have, and also much harder to talk about them. And I think complexity at the sort of when it's been made explicit and architecture level, is a lot easier to reason about and understand than to and manage, and then when it's all hidden inside your code. And also, there's complexity is not just in the application, but also in terms of the operations. I mean, for me, I've pretty much my entire career, I've been on call. I've been building applications and then running it myself. So for me, the need to be on call and operate and run infrastructure, it takes a lot of my time. And when it comes to serverless, a lot of that becomes somebody else's responsibility. Somebody else who can do a much better job than I can. Somebody else who has designed and built the systems that runs my code in a way that's highly redundant, highly resilient to failures. Yes, AWS still has outages, and you can do things about that yourself in terms of building your system to be multi-region, so that you don't have that single point of failure at the region level. For business, where some business, that makes sense. But by and large, the kind of failures that you see nowadays that affect the entire regions are fairly infrequent compared to failures that people have in their own infrastructure that they're running, that people don't talk about it because it's all hidden. No one knows about it. When I was working in banking before, we used to have like crazy network outages all the time. Sometimes the entire trading system would be unavailable for 2 days, but no one talks about it because it's inside one company. But yeah, infrastructure failures happens. And it's usually better for you when it happens to someone like AWS, where they tend to be pretty good at fixing it quickly.
Okay. Yeah, that sounds awesome. And you're right. Systems fail all the time, but and when systems fail internally in different organizations, is no big deal. But when systems fail at the cloud level, all of a sudden everybody is freaking out. Like,
Yeah, everyone talks about it, but it doesn't mean that it's the same with like when an airplane crashes, everyone talks about it. It's big news. But that in terms of travel, that is the safest way to travel compared to by car, because car accidents happens all the time, but no one talks about it because it doesn't make the news.
yeah, that's an excellent analogy. That's an excellent analogy. Okay, so one question I would like to ask is, why not containers, right? Why not a managed container service like maybe ECS or AKS, or maybe even Kubernetes if you want a little bit more control over the environment, right? Um, do you have to always go to serverless as the default, or is it does it yeah, do you have to always go to serverless as a default?
Yeah, so I think the sort of the most serverless advocates you talk to will tell you to apply a serverless first mindset, not serverless only. So which basically just means that if you can build something with serverless technologies, you should prefer that. Until you can't, for whatever reason, then use containers absolutely. Um, the problem with a lot of the sort of Kubernetes is that Kubernetes is not really designed for developers. Now, if you've got a large organization, there's a lot of different workloads, and you've got 10 millions in the bank that you can use to hire a bunch of a whole team to look after a Kubernetes cluster. It might make sense for you, but it doesn't make sense for a lot of most companies out there who just want to build a product to sell some socks or to sell some cupcakes or whatever. And the thing with Kubernetes is that it is quite a complex machinery. There's a lot of things you have to be responsible for, and that takes a lot of time. With the sort of managed services you get nowadays, so that's making things a lot easier. But there's still a lot of work you got to do. I think ECS for me is easier to use compared to Kubernetes, but that's just maybe because I'm more familiar with AWS in general. But when I need to run containers, I tend to use Fargate, which is again less things for me to worry about. I just need to worry about definition for my container and describing the Fargate task. But you see, problem things like okay, I need to describe the different container layers I need to install, and there's probably going to be some patching involved in terms of updating the base images I got, as well as the node runtime, making sure that I've got the latest security patches or whatever runtime I'm using, as well as configuring the actual container environment so that I've got the agents running to collect my logs, my metrics, and other things like that. And then I got to write the 2 lines of code my application actually needs to, I don't know, to talk to a database, to read some data from database or whatever. So there's still a lot of work that I need to do to maintain that environment. If there are cases where I actually need to have more control of my execution environment, then yeah, sure, containers is absolutely fine. And I wouldn't go straight to Kubernetes because again, that means a lot more additional things you got to do in terms of managing that and building that compute platform, and so kind of putting you directly again, you're competing directly against people like AWS and Microsoft in terms of building a compute platform. For some companies, that makes sense, especially companies that need to actually compete against AWS or Microsoft. But for most businesses, that's not what you're trying to do. That's not what you're selling to your customers. So for you to be building your own compute platform is just wasting a valuable resources that you have. And But yeah, so in terms of using serverless, there's cases where it doesn't make sense for you to use serverless. It could be the case of say, okay, I've got a really high throughput API, and if I'm using API gateway and Lambda, the cost of that is going to be prohibitive. It could be much more expensive, even when I factor into the account. Okay, if I was to run this workload, this API on a container, I need someone with the knowledge to be able to set things up, to secure them, make sure that we're not going to have someone hacking, being able to break into our execution environment, so all the network settings are correct and the container images are regularly patched and all of that. I need to hire someone to do that. So that can be £5,000 a month, could be £10,000 a month or whatever. Now I need to hire the right people to come in and do their job. But sometimes when you've got a really high throughput API, the cost of running that API, say on Lambda and API Gateway, is going to be much more expensive than paying like a team of people to look after a container environment, plus whatever you're going to be paying on ECS. So there are cases where it makes sense, where serverless doesn't make sense anymore because it's too expensive. Or it could be a case where for the zone, like I mentioned, we had a big sports streaming platform. We had over 2 million concurrent viewers. What's interesting about the zone is that because it's a live sporting event, so like nobody logs in until about 2 minutes before the event starts. Imagine Super Bowl, everyone logs in about 30 seconds before. So your traffic pattern is like steady, 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 and then they'll go from like 500 RPS to 50,000 RPS within like 30-second span. So Now on Lambda, you're going to hit some scaling limits. So Lambda is very scalable up to a certain point. It's great for unpredictable when you've got traffic that's unpredictable, but it's not so high that you're going to hit the scaling limits. So with Lambda, you've got this regional limit called the burst capacity, which says you can go from 0 to 3,000 concurrent executions or number of instances, individual instances of your Lambda functions in the whole region. Beyond that, you can only go up the concurrency by 500 per minute. So to reach a peak concurrency of 10,000 concurrent executions, it's going to take you 7,000 divided by 500. So it's going to take you 14 minutes to reach that peak concurrency. So if your traffic demands 10,000 concurrency to handle, and you have to scale from 0 to 10,000 in 30 seconds, then you can't do that. So there are cases where you're going to hit those scaling limits, which means Lambda is not going to be a good choice for you. In the zones case, any API that's along that critical path where someone comes in and logs in and start clicking on a stream to start watching a football match or a rugby match or whatever match, anything along that critical path, we say you can't, you shouldn't use Lambda unless you or an API gateway, unless your API is really cacheable. You can just cache on the edge, and so your actual traffic to your service is really minimum. Then everything have to be running on containers where we have more control around scaling, and we know when those scaling those spikes are going to come because it's based on the schedule of those sporting events. So with containers, it's much easier to say, okay, set the number of containers from 5 to 500, and you can do that kind of scaling on a schedule a lot easier than to say pre-warm number of Lambda functions so that you can hit that peak concurrency before you need it. So that's where one example where, okay, based on concurrency requirements, we're going to hit some limits. So Lambda is not a very good fit. Equally, you have workloads that maybe, for example, you're doing a big ETL job that takes a long time to run. And on Lambda, you have a limit around how long a single execution can run, which is 15 minutes. So even to run workloads that are regularly takes longer than 15 minutes, then again, you can, rather than working around these limits, just put it into a Fargate task and run a container instead, based on a schedule of when you need to run those ETL jobs. So there's a number of cases where serverless is just not a very good fit, or Lambda is just not a very good fit, based on cost efficiency or based on the scalability requirements, or maybe you've got something that's really requires like a long running server, like things like I used to work for game studios, and one of the things I used to build one game was like a mobile online multiplayer game where we have to build like a UDP protocol for a game server, and so we needed like a long running server. So again, that was something that it doesn't fit with the Lambda's execution model. So there are lots of cases where you still want to run containers or some kind of a server. Doesn't have to be container. It could be ECS. It could be a EC2 as well. There's nothing wrong with EC2. No, if all you got is one workload, you don't need to have different kind of workloads running on the same servers, same pool of servers for efficiency. You can just run the Elastic Beanstalk or just EC2, vanilla EC2. They're just they're just the same as well. But yeah, so serverless is not the only option. But where you can use serverless, you probably should, because it's going to give you a lot of things out of the box without you having to work very hard for the same level of scalability, redundancy, and the scalability and security.
Okay, so I'm going to ask you a slightly controversial question. And just to give a disclaimer, I am an employee of Amazon, so yeah, so just putting my cards out on the table. But there was this whole controversy. I don't know if you know about it, concerning Amazon Prime Video switching from serverless. Now, I don't work for Amazon Prime Video. That's a different team. It has nothing to do with me. But what is your thoughts in the whole story? Because a lot of people came out and said even Amazon is moving away from serverless because they don't believe in it and I read a lot of stuff, but I just wanted to, as someone who is in that space, who does consulting, who works with people, you have a lot of experience. What's your thought on the whole migration?
Yeah, sure. Because the first thing to mention is that it's not Amazon, it's not Prime Video, it's one specific team and one specific service that made a decision that that had to evolve over time. And if you look at if you read the blog post for what it is, without having that mindset about okay, now Amazon is moving away from the serverless, and just actually read it for what it is, you see, first thing they said is that we had this service that already exists. They got some tool they need to build to analyze videos. They didn't think it's going to be very high throughput, so they wanted to use serverless. And they talk about how it allowed them to build something very, very quickly, get it out into the into production, so people can start using it. And then over time, they found that more and more people start using it because they got this thing and it's useful, and people start using it more and more. So traffic grew, which means the context in which they need to operate for this service has changed. So all they've done is adapted to the actual requirements for the service, because your context is not static. You may one day start with 50 requests per second, but maybe like 2 years later, or in their case, maybe it's now 10,000 requests per second. So the actual requirements and the cost efficiency, calculation is very different, compared to the before and after. So what they've done is classic evolutionary architecture, where you adapt your architecture based on actual reality of what you're dealing with. And there's nothing wrong with that. It's actually like a really good case study for evolutionary architecture, except people look at it with like specific lenses. They want to just see that one thing, and so like the whole thing was got blown out of proportion. But no, what it did exactly what I talked about earlier, where for the zone, you got actually no, the example I gave was the if you got a really high throughput API, you should know serverless probably not a good fit. So they went from I need something quickly, it's not going to be high throughput, to now we've got a very high throughput system, and serverless doesn't have the right cost equation for us anymore. So let's move that to containers instead. And even though they moved I think it was the orchestration that they moved away from step functions and serverless and Lambda function to running orchestration within like an EC2 container or EC2 virtual machine or containers. I think maybe sorry, it was ECS, right? Yeah. So one thing they actually talk about, which I thought was interesting, that people didn't pick up on, or at least didn't talk about enough, is the fact that people talk about vendor lock-in. This is a classic example of how you put a bit of a modularity into your code, and you're able to move the code from Lambda into containers really easily without having to do entire rewrite. And that's what they talk about in the blog post as well, that they're able to do this migration fairly quickly without doing a big rewrite. And again, that kind of just knocks away some of the arguments around the vendor lock-in, why you shouldn't use Lambda because you can't move it away. But that's just not true. And this is another good post, a good point that goes against this argument about you can't move your code from Lambda to something else, which again, completely not true. And again, going back to the sort of serverless first mindset, use serverless when you can, and you should know when you can't, don't use serverless. And again, in this case, their context change from where it works to where it doesn't work from cost efficient point of view. And they did the right thing. They did what any reasonable person would do, and they adapted. And should be congrats to them. And again, this is one team, and you can easily look at another team's services in the Prime Video that doesn't have the same level of throughput, and they'll probably still be running stuff in the API gateway and Lambda. And the same with Amazon's. I know a lot of services teams use API gateway and Lambda and step functions, and I know some teams use step functions for the control plane stuff because they give you that additional robustness and the redundancy for making system more resilient and easy to debug. But then when it comes to control plane operations, you're usually not talking about high throughput use cases. And so again, it's not just about using one service for everything. There's no silver bullet. And I think it's just a shame. It's a really good article that talks about how you should adapt and evolve as your context change, but it was just taken completely out of context. And also is one team, one service. It's not like Amazon. Sure, it's one part of Amazon, but it's it's one team, one service.
Yeah, it's good. I think it's good you said that because yeah, Amazon is a very massive company with multiple teams scattered, all working autonomously and everything. And part of the reason I wanted you to speak on it as well is that every time, I'm always asked these questions, right? And every time I am saying certain things, it's like, oh, you are just you have conflict of interest or stuff like that. So it's good you said this as well, because even like you said in the article, one thing they did mention was that they were able to very easily bring all those services together. So they're still deploying individual executable units. The only difference is that now they are running together in the same environment, right? And yeah, and it's difficult if you had one executable you had to break apart, right? Aha. If you are starting from a monolith and you're trying to do that kind of change down the line, you wouldn't be able to do it. But with serverless, it becomes very, very, very trivial.
Yeah, 'cause I think they talk about in the article how before the steps are, already broken up into individual Lambda functions that get triggered by a step function. So they kept most of the sort of same flow, which means they were able to reuse existing modularity at the code level and then bring them together just at the sort of orchestration sort of the workflow bit and put it into ECS so that you got different bits of module, different bits of code that gets triggered by your own sort of control flow as opposed to step functions. So that's that modularity that you kind of that Lambda kind of forces you to start with, kind of how it becomes helpful later on as they move to a different architecture.
Hey, my apologies for being in and out. I'm having connectivity issues. Hopefully, this question wasn't already asked or the topic discussed. But Yin, and this tends to come up every other video that we talk about, is developer incentives. And, I don't see job descriptions or tech screenings where they say must have serverless, must have lambdas, must have Azure functions. What I do consistently see is must have Kubernetes, right? Containers, containers, containers. And the parallel to that is must have microservice experience. Microservice, 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 right? And so it incentivizes people that want to be marketable in their professional practices to use microservices when it's not even warranted, when it actually even potentially becomes a threat to the business in regards to profitability or reducing expenses, which is one of which probably the same. Do you have any feedback, opinion, or guidance on how to focus on engineering, do the right thing versus giving in to politics and the human factor?
I don't have an answer for that, unfortunately, and I think I do see a lot of that as well in terms of people asking for things like microservices or very specific technologies before they even make the decision to go with those. Oftentimes, go with those because that's what everyone else is asking for, and let's just kind of copy what everyone else is doing. And it's another symptom of this. Big tech warship, if you like, where everyone kind of just follows what the Googles and Amazons and other big tech companies is doing. They're using containers, they're building microservices, which do the same thing. But what works for Amazon probably is not going to work for you if you're like a 10 people company that's selling cupcakes. You don't have the same level of traffic, you don't have the same level of organizations. Microservices is great for scaling organizations, not for your applications. So now, if you don't need to scale your team to 200 people, you probably don't need microservices. And another common things I see is that the people confuse, microservices, which is architectural style, how you build systems, with the specific technologies that often get used, which is containers. Containers doesn't mean microservices or vice versa. And you can build microservices with serverless or containers. It's all the same, and you can build monolith applications using serverless as well. And in fact, most of my applications, I build them quite monolithically. I've got one big AppSync API that serves the whole front end with lots of Lambda function behind them. Sure, you got different moving parts in terms of AWS resources, but it's still a one big monolith. And everything I touch it gets deployed together. Makes deployment a lot easier in terms of thinking about things and also reasoning about the application as well. and that works just fine when it's a small team of people that you don't need to scale them to 200 people. But when you need to have that large organization, that's obviously very different in terms of focusing people more on this, doing the right thing for the business. I don't know how you can translate that to the sort of job spec. And one of the important things to keep in mind is that the value of job spec is not necessarily to bring in the right people, but to filter out the wrong people. So the value of job spec and those keywords for me really is just to filter out the sort of hundreds of CVs and into a smaller number of manageable CVs that touch on the right the sort of the range of things that you want people to have. But like I said, a lot of people just throw a lot of alphabet soup onto their job spec, and yeah, I don't know what's the right answer for that.
You have to play the game.
You have to play the game. Yeah, exactly.
So, so here's a question, and I mean, I'm not looking at you as the authority figure on this, on everything I ask, but who is asking for this? Who is asking that you can only be in a marketable professional developer if you have 5 years experience at least in microservices. If you have 5 years of experience at least in containers, if I doubt if the actual client that is focused on the business, how do we automate this business solution, right? I doubt if they're the ones that are saying Kubernetes, right? These are business stakeholders. Like they speak in the language of accounting, profit, right? Who is asking for this? Is it is this industrial complex like the consulting firms? Like who is it?
Honestly, I don't know. I wish I know. I wish I know.
No, I think so. What happens is there's a saying that the most dangerous people in an organization is not the CEOs who speak in the language of business, like you said, Scott. Is usually those who have just enough information to be misled, right? They know a little bit about tech. So the moment they talk to someone who just says, write everything in with Kubernetes, it sticks. And all of a sudden, maybe that person is high up, like a CTO kind of position. And then he comes to the company and he's like, we are going Kubernetes and we need consultants for Kubernetes and we need to put it in our job descriptions. And I think that's what usually happens. Is usually technical leaders who are just technical enough to know a little bit of terms and stuff like that, but not technical enough to know what are the trade-offs between one decision and another and where you should use one or the other. I think that's where it comes from.
So let's think about the impact, right? And look, you have to correct me because sometimes I don't know what I'm talking about, right? But if we think about the impact of containers, how easy is it for an arbitrary backend developer to get their work done that is dependent on a containers platform? Is it abstracted away enough that they can still focus on deploying without an issue? I think with serverless, I mean, maybe I'm biased, but I think it's easier. But I don't have experience with containers. I don't have experience with Kubernetes. Is there a consequence for your developer that's supposed to help the business adapt to current conditions? Is your containerization, does it impede progress of your typical developer, where they're forced to know the implementation details of infrastructure? Whereas my bias is with serverless, it's serverless. Like the context of that term is we're going to abstract that away and it's going to be handled behind the scenes.
Yeah, I think there is a business impact, especially around the productivity of your developers and how much of their time is actually going to be focusing on doing things that add value to your business versus just running your infrastructure environment and operating and the patching it and being on call and the response and respond to errors and problems that shows up in production. Obviously, that's been my life for most of my career, being on call and dealing with infrastructure, and that's why when the server became a viable option, that's I just had jumped head in there and haven't looked back since. And I think that the greatest, probably the worst misconception around containers is that it works on a machine and it's ready for production. And it absolutely is not. there's a big distance between when it works on my machine, I've got a container running on my machine, to when it's actually ready for production. There's a whole layer of things that need to be taken care of, and they're not things that you can just do once and forget about. The fact that the security setup need to be continually updated, your machine images that need to be continually patched, and you need to constantly probably revise your scaling parameters and configurations, and there's also things like to actually do containers well, you probably do need some help. Things like container scheduler, like Kubernetes, ECS, just so they can do some of the basic things around making efficient use of the resources that you're running under the hood, your EC2 instances. And people talk about how containers can scale very quickly, and that's absolutely true up to a certain point. If you ever need to scale quickly and beyond the number of spare EC2 instances you've got running, you realize, wait a minute, scaling container is not 20 milliseconds or 20 milliseconds. It's 5 minutes for the next EC2 instances to be available, so I can allocate to that my containers into that environment. So where you're running EC2 and then ECS on top of that, and then your containers application. Now you're looking at managing 3 layers of things before you even get to your actual application code. The 2 lines of a web API that you're writing that actually deliver value to your customers. So there's a lot of layers to get to. What I call yak shaving. So, the things you gotta do to get to doing the thing you need to do or want to do. So there's absolutely impact in terms of a business, just in terms of how quickly things can be done, and also I probably don't need to remind people just in terms of how often you see misconfigured Kubernetes or container environments that leaves things like the Kubernetes port open public. There's actually some tools you can just go online and just scan open ports just on IP addresses. You will find Kubernetes ports being open. And there has been instances in the past where those open ports, people were able to compromise containers environments and take over them by just talking to our open Kubernetes port. So again, there's a lot of a place where you are responsible for your own infrastructure security. There's a lot of ways for you to mess up. And the same goes to other things like OpenSearch. I've seen Elasticsearch being compromised. I think there was like a bank a while back that lost a bunch of people's data. It was one of the biggest data breach ever, and it was OpenSearch being open. Again, that's when you're managing infrastructure, there's a lot of ways for you to make a mistake and you wouldn't even know it.
So sorry, to clarify a little bit, Scott, right? Because I'm also someone who uses containers and Kubernetes and everything. And I think a better way to think about it is this, right? You have EC2, or should I say Azure VMs on an extreme, and then you have serverless on the other end. And in between, there are all forms of sliders, right? So you can have like, there are all forms of sliders in between. And Kubernetes falls a little bit towards the EC2 line, right? And in my experience, what I've seen is that Kubernetes is better for companies, maybe mid to small to mid-sized companies that already has an infrastructure team dedicated, and probably they want the ability to be able to move between clouds easily, because what Kubernetes is like an abstraction for cloud. But from a developer standpoint, all you're just writing is to a Docker file and you're building a container from there. What I will say though is that Yan is right in the sense that there's a lot that could go wrong. There's a lot of configuration that goes into Kubernetes, and for most businesses, it doesn't make sense for them, right? And even the justification of we want to be able to move between one cloud and the other. Realistically, how often does that happen? Almost never, right? It does happen, but it's not so commonplace that you have to build it into your infrastructure upfront, right? So yeah, I know the question you asked was how does that affect the developer on a day-to-day basis? If it's properly managed, right? Both of them can be used to do microservice architecture, right? So the developer doesn't really know how the rest of the infrastructure is all put together. All they are focused on is that one microservice, that one container, that one serverless function.
And something else that I'm curious about Yan's input is I've been on a couple projects, And I'm also curious about your feedback, Odie. Cost analysis has never ever been done on choosing the solution for computing, whether it's containers, whether it's serverless. The question of how much is this configuration going to cost within the next, like on launch versus maybe 6 months, at how many users is this cost going to be? It's never ever been done based on my experience. Have you guys had different experiences? Is this really, I mean, is that like diminishing returns to go through that effort? I would think it's for the business, but is it a coincidence that these questions are never posed?
I have seen it done, but those things are difficult for multiple points. For one, the business often doesn't know what they would expect in terms of traffic, in terms of user behavior. When it comes to serverless, your cost is going to be much tightly coupled to the actual traffic, actual usage. So if you don't know what the usage is, to expect, you're not going to be able to project how much cost is going to be you're going to incur in terms of using serverless, Lambda functions, API gateway, whatnot. Whereas we have containers, it's much easier to predict because you're talking about big ballpark number based on the number of instances you're going to have to run. This is going to be how much it's going to cost you to run this infrastructure. So when it comes to containers, it's easier, it's more predictable, but it's much less efficient because you're spending a lot of money just going to waste on for resources that you're not going to end up using. There are companies that are much better at doing this than others, and for people who has been using serverless or AWS for a while, you can actually, especially when you come to a project where you are, say, migrating an existing system. Oftentimes, I'll ask my clients in terms of what's your use traffic like, so that you get a rough idea in terms of the sort of user traffic you're dealing with, and then based on what the architecture is doing, you can probably do a decent job of just estimating or projecting what the likely cost for that system is going to be. If it's going to be running on API Gateway and Lambda, because you can kind of project based on the likely number of requests you're going to be handling, and how much each request is going to cost, as well as the number of database calls you're going to be making based on what your system is doing. So based on what you're doing, you can actually do a really good projection for how much it's gonna cost you if you know what kind of the inbound traffic pattern is going to look like. So if you have that data because you're working on an existing system, then you can actually do a very good job. And I have seen companies do a very good job of projecting what the cost is going to look like, and they use that information to choose whether or not we should be using step functions, or we should be building this by writing Lambda functions and doing our own orchestration, or running a bunch of containers. It's not always easy, but I have seen companies do it.
Yeah. So I think we've gone a little bit past an hour. Um, First off, there was one final question we wanted to ask about where the name the Burning Monk came from, if you can speak to that.
Yeah, so I'm a big fan of Rage Against the Machines. On the debut album, they had the Burning Monk, which is this this Vietnamese monk who set himself on fire in protest to the American influence in the north and south of Vietnam back in the day. And so yeah, that's where the Burning Monk online name came from.
Interesting, very interesting. That's good to know. Yeah, so tell us about what you're up to. I know I read your blog. Yeah, so just go ahead.
Yeah, how do people get
Yes.
in contact with you? Or how do people keep up with you? How about that?
Oh yeah. So if you go to theburningmonk.com, you'll find my blog, and also from there you can find my links to my video courses. I've got a bunch of on-demand video courses around the serverless development. There's a course on AppSync, which you build like a Twitter clone from both a full stack Twitter clone using AppSync, and kind of show you how to use AppSync and how to run it and all that. Also, I've got a new course called Testing Serverless Architectures, which kind of shows you how to test serverless architectures, covering API gateway, AppSync, step functions, and the event-driven architectures, which all have their own kind of caveats when it comes to testing. And I've got a coming workshop coming up as well, Production-Ready Serverless, which is more of a like end-to-end training around how to write Lambda functions, how to deploy them, how to secure your pipelines, how to do observability, how to do end-to-end sort of testing, and all these other various different things. So it's more like a zero to hero kind of training around the serverless development. But then some of the other video courses dive deeper into specific topics like testing, for instance. And other than that, I also do consulting work, which ranges from just doing advisory course with clients to training to actually just building entire system for clients, which I've done a couple of times. I'm the one-man backend team, set up your entire AWS environment, AWS organizations, and your entire application on the backend side at least. I've done that quite a few times, and partly because I can use serverless, or I can do the job of that. That would always that used to take a whole team to do. I can do it on my own in a fraction of the time because I don't have to worry about infrastructure.
And you also maintain a podcast. I think I
Oh
saw
yeah,
that on your blog.
got
Okay.
a podcast as well called Real World Serverless, which not quite as regular as I used to. It's just hard to find time to do the recording, editing, all that. But still try to push out episode every couple of weeks or so, just so that I can talk to other people and share their stories with everybody, because there's a lot of maybe less flashy, less well-known companies out there that are not big tech companies that are doing some really interesting stuff around serverless. I've got some of them are clients that are in the sort of financial. So I was talking to someone who's one of the first sort of serverless first banking companies. They're doing some really interesting stuff, and lots of other companies are doing some really cool stuff. I just want to get their stories to the public so that everyone can read about this, and it's not just big fancy tech, but there's a lot of other business that are making really interesting use cases for serverless.
Yan Trey, thank you.
Thanks,
Yeah,
Scott. Thanks, Audie.
yeah, thank you so much. All right, bye.